Welcome to the Diagnostic Clinic. I am your lead strategist, and today we are looking at the Cambridge Physics syllabus, specifically code 0625, and diagnosing exactly why so many hardworking students hemorrhage marks on what should be the easiest questions on the paper. We are going to look at the secret language of physics, decoding symbols and units, but we are going to do it through the lens of pure exam strategy. Picture the exam hall. The timer is ticking. The tension is high. Let me introduce you to two students we see every single year. First, we have Alex. Alex overloads every answer with raw physics facts, completely ignoring the analysis the examiner is actually asking for. Then we have Sam. Sam rushes, entirely missing the command word requirements. Today, we are going to look at their flawed answers, covered in red pen marks, and we are going to prescribe the exact cure. Let us jump right in.
Here is a fundamental question you will encounter, often disguised within a larger practical paper. How do physicists communicate complex ideas without writing a single word? Or, as the exam paper usually phrases it, draw the circuit diagram for the apparatus shown. When faced with this, our student Alex tries to draw a highly detailed three-dimensional battery with shading, sketching out every single copper wire. Alex spends 5 minutes on a 2-mark question. Sam, on the other hand, draws a rushed, squiggly line, assumes the examiner knows what it means, and moves on. Both students score absolute 0. Why? Because they do not understand that physics has a universal, non-negotiable shorthand. Examiners are not looking for art, and they are not looking for guesswork. They are looking for the exact code.
So let us define exactly what this code is. A scientific symbol is a universal visual shorthand or a very specific letter used to represent a physical quantity, a unit of measurement, or an electrical component. This is the foundational vocabulary of the 0625 syllabus, and it applies equally to 0651, 0652, 5054, and even A-level 9702. You cannot invent your own symbols. The examiner is checking your fluency in this specific language. Just like learning the alphabet allows you to read any book, mastering this specific code makes the vast, complex universe of physics completely readable, and more importantly, perfectly answerable under extreme exam conditions.
To fix Alex and Sam's exam technique, we are going to break this explainer down into 5 manageable diagnostic areas. First, we establish the language of physics. Second, we dissect core electrical symbols. Third, we upgrade to advanced circuit components. Fourth, we diagnose core quantities and units. And fifth, we master advanced physical quantities. As we go through these, we are going to reveal the PEEL framework. That stands for point, evidence, explanation, link. This is the exact structure that top-tier students use to format their answers and extract every single available mark from the examiner.
Let us begin our first major diagnostic intervention. Section 2, Core Electrical Symbols. We are going to look at how command words dictate your response here. If a question simply says identify, that is a 1-mark recall question. Do not waste time. But if it says explain the function of, you need to deploy the PEL structure. Before we dive into dissecting these command words and applying our framework, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Look at this comprehensive visual dictionary pulled directly from the Cambridge syllabus. When Alex looks at this massive list of components all at once, panic sets in, and Alex tries to blindly memorize it like a phone directory. When Sam looks at it, Sam just skims it, figuring it will just make sense on exam day. Both are fatal strategic errors. The strategy here is not brute force memorization. It is about logical grouping and understanding the root visual language. We need to train your brain to instantly recognize the category of the symbol before you even identify the specific component.
Let us do a live diagnostic on logical grouping. Look at how we can immediately differentiate our power sources from our measurement devices. A single cell is just a long line and a short, thicker line. A battery is simply a series of these cells connected. Contrast that with our measurement devices, which are beautifully simple. A circle with an A inside is your ammeter. A circle with a V is your voltmeter. Now imagine the command word is compare. If you just say one has an A and one has a line, you fail. Using our PEEL framework, you make your point. Ammeters measure current, while cells provide power. Your evidence. The ammeter is denoted by a circled A, whereas the cell uses parallel lines. This is how you structure a winning answer.
This brilliantly illustrates how a base symbol evolves, which is a common trick in multiple-choice papers. Notice how the simple blank rectangle is the universal root symbol for a fixed resistor. It just sits there resisting at a constant rate. But watch the modifiers. If you add a diagonal arrow straight through it, it becomes a variable resistor. The arrow literally implies adjustability. Add a flat-lined stroke, and it is a thermistor, reacting to thermal changes. Draw arrows pointing towards the rectangle, representing incoming photons, and you have a light-dependent resistor. The rectangle is the root word, and the arrows are the adjectives. If you understand this grammar, you never have to blindly guess again.
We are now entering Act 3, the transformation. Section 3, Advanced Circuit Components. This is where the red pen marks on Alex and Sam's papers are going to transform into green check marks. We are going to rewrite their answers live using our guided strategy, explaining exactly why each structural change we make adds guaranteed marks to your final score. This is your physics success blueprint in action.
The Cambridge syllabus strictly differentiates between core and supplement material. Core components, like lamps, basic switches, and heaters, are your fundamental building blocks. They just use the energy. But the supplement components act as the strict grammatical rules for your circuit. These are your directional controllers, like diodes. They actively dictate exactly how and where the current is allowed to travel. When an exam asks you to describe the function of a diode, Alex brain dumps a massive paragraph about semiconductor doping. That gets 0 marks because it misses the command word requirement. Using PEL, we write, point, a diode controls current direction. Explain, it only allows current to flow in one specific direction, blocking reverse flow. Stop writing there. You have the marks.
It is fascinating how visually logical these advanced symbols are if you stop rushing. Look at the highlighted diode symbol. It is a triangle pointing toward a flat vertical line. It literally looks like an arrow hitting a solid wall. That tells you the function instantly. Current flows the way the arrow points and is blocked by the wall. Now look at the light-emitting diode right below it. Sam lost marks here by drawing a regular diode. The supplement symbol for an LED is the exact same standard diode, but you must include the tiny arrows pointing outward to represent emitted light. If you omit those arrows, you are drawing the wrong component and you lose the mark. Accuracy is everything.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let us shift our focus from the visual dialect of circuits to the mathematical dialect. Section 4, Core Quantities and Units. Welcome to the interactive workshop.
This is Challenge 1, the data scan. You have a 60-second visual timer running in your head right now. Look at this complex data source showing core physical quantities. In the exam, you have to extract this from memory instantly. You do not get a cheat sheet. If the command word is calculate the weight and you give your answer in kilograms, you just lost the final mark. Alex constantly does this, brain dumping numbers without checking the unit. The core trend you must extract right now is strict matching. Mass is m in kilograms. Time is t in seconds. You cannot mix and match.
Moving to Challenge 2, Find the Flaw. I'm going to read you Sam's actual flawed paragraph from a past paper. The car has a mass of 1,000, so it accelerates at 5, giving a force of 5,000. What is the flaw? Sam rushed and dropped every single unit. The examiner commentary on this exact mistake states that omitting units results in an automatic deduction of the final calculation mark. The corrected version must read, mass of 1,000 kilograms, accelerates at 5 meters per second squared, giving a force of 5,000 newtons. See the hidden mechanics narrative? Mass accelerates to create force, and applying that force over a distance gives us work done in joules. Always include the unit.
Challenge 3, Speed Writing. You have exactly 30 seconds to write one perfect PL paragraph explaining how current and resistance interact, using their proper units. Go. Remember, you have to use the exact terminology. Time is up. Let us review. Did you point out that current, symbolized by capital I, is measured in amperes? Did you state that resistance, symbolized by capital R, is measured in ohms? This logical grouping is heavily tested in waves and electricity. If you do not pair the concept with its exact mathematical shorthand, the examiner assumes you do not actually understand the physics.
We are now entering the final phase of the clinic.
Section 5, Advanced Physical Quantities. This is where we consolidate the complete physics answering system for those of you targeting the absolute highest grades on the supplement content. We have 3 golden rules that guarantee top marks. Rule 1, command word decoding. Rule 2, Peel framework application. And Rule 3, the time management matrix, which dictates you spend exactly 1 minute per mark available. Let us apply this system.
Look at this comparison graphic showing the progress from core to supplement units. Often, stepping up to the supplement level simply requires higher precision and unit conversion. This is where the time management matrix is crucial. Sam looks at a question giving time in milliseconds, rushes the calculation, and plugs the raw number into the velocity equation. Massive fail. The matrix tells you to slow down. 1 minute per mark means you have time to look at the m's for milliseconds or the mu-s for microseconds and convert it back to base seconds before you calculate. Same with pressure. Core gives you newtons per square meter, but supplement concisely expresses it as pascals. Do not let prefixes cost you your A star.
At the supplement level, you also encounter entirely new quantities. Look at momentum, symbolized by lowercase p and measured in kilogram meters per second, or impulse, and the spring constant k. If the command word is determine the spring constant from the graph, Alex will write an essay about springs. Wrong. Decode the command word. Determine from a graph usually means calculating the gradient. So your point is that the spring constant equals the gradient. Your evidence is the specific change in y over the change in x from the data. Your explanation shows the calculation, and your link provides the final answer with a strict unit of newtons per meter. Clean, precise, and fully marked.
Our mathematical shorthand even scales up to astrophysics. The supplement syllabus introduces space physics, including the Hubble constant, h0, which measures the expansion of space itself. It is measured in inverse seconds. Students often panic when they see space physics because it feels too big. But remember our diagnostic system. It does not matter if you are calculating the resistance of a tiny wire or the expansion rate of the universe. The rules are identical. Decode the command word, apply the PEL framework, mind your units, and watch your mark potential reach 100%.
Mastering these symbols isn't just a memorization task, it's about learning to read the universe's instruction manual. By systematically grouping these core and supplement symbols and applying our strict exam techniques, you are becoming fluent in the fundamental language of reality. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
So, with this universal dictionary firmly established in your mind and your exam strategy cured, what incredible physical phenomena will you choose to decode next? Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here.